Hello everyone, you are welcome to today's lesson. In today's lesson, we are going to look at the topic that we have on our screens, the Earth as a sphere, what we normally refer to as global mathematics, global maths. Okay, so this particular topic is all about finding the distance between 2 points on the Earth's surface, basically. And this is what the pilots they use. So the basic thing that we are going to do in terms of our learning objective would be you should be able to recognize that the earth is what is a sphere rather than a circle. That is one. Then two, you should be able to distinguish between great circles and small circles. You should know longitude and what and latitude. You should be able to locate points on the Earth's surface. Okay, and last but not the least for this particular class or this particular lesson, the lesson one of this topic, we'll be looking at how to find the difference in angle between two what points. And aside all that I have mentioned, okay, we will look at maybe if time allows, okay, so the circumference of a great circle and what of a small circle. So please stick and stay with me. I'm your usual facilitator, Mr. Hackman. Okay, so I'm going to skip the lesson objective directly. I've mentioned, okay, some of them. Now let's look at, okay, the longitude and what and latitude or latitude and longitude. JHS, you did social studies. Okay, so you have a fair idea of what you have here. Okay, so I am going to be very, very brief. Okay, so latitude usually will vary from 0 up to what at the equator to 90 degrees. So the angle will be 0 degrees up to 90 degrees and is drawn, okay, north and south of what of the pole. So anytime you are talking about latitude, the measurement is done relative to the south and what and the north. So that's the more reason why you have there. So these circles that we have here, okay, will be our latitude. Latitude basically will be lines, and the lines that you have there will always be parallel. So the lines on the Earth surface, okay, that will be parallel, will be the ones, okay, taken relative to the north and south, and that will be latitude. So latitude basically will be horizontal line. And one of the special latitude that we should all know will be what? The equator. Then you come towards longitude. Longitude will also be imaginary lines that we measure, okay, east and west of what? A vertical line, and that vertical line is what we call the Greenwich what meridian. Like I said, the latitude is measured, okay, north and south of what? The equator, which is the baseline. However, the longitude is measured, okay, east and west. So east and west of what? Okay, the Greenwich what? Meridian. Okay, and that one, the angle will measure from what? 0 up to what? Up to 180. 0 up to 180. But if you look at this critically, so it means your Greenwich meridian will be 0. If you move away, the farther you move away, your bigger your angle. In the same way here, the farther you move away from the equator, the bigger your angle, okay, up north and what? And okay, down south. Please take note. So in actual fact, okay, this is the situation that we are looking at. So this one combines both the longitude and what? And the latitude. So you can see that the latitudes are parallel. Okay, they are parallel. However, the longitude, they meet, they converge, okay, at the North Pole and at the South Pole. They meet, okay, but latitude, they don't meet. Am I clear, my professors? Okay, if you want more information about longitude and latitude, okay, I have a whole lot here. Okay, so you can read this and you appreciate all that you have there is in plain what? English language, simple, okay, sentences and language. So you should be able to relate. And I've told you, because of time, we are not going to go through all that. Okay, so now let's go and look at what great circles and small circles. Okay, so basically great circles are okay circles that divide the globe, the earth, okay, into two equal halves or bisect the earth into two equal halves. So any line, okay, that will bisect or divide the earth into two equal halves is referred to as a great circle. And remember we said, okay, I think I didn't mention that, but I can equally mention that the only latitude, okay, that would divide the globe, okay, the earth into two equal halves will be the equator. Let me go back and you will see that. So the equator is what divides, okay, the earth into two equal halves. Let's say, assuming you have an orange, if you want to cut through, okay, and get half, it means you have to cut through the middle this way, you get half. Okay, and that line that will be there will be your equator. If you have an orange and you cut through the top from the north, okay, to the south, always, okay, you will get what? Your orange divided into two equal halves. So in that case, okay, you are going to get what? All longitude to be what? To be great circles. But for the latitude, the only one that will divide your orange, in this case, the earth, okay, surface, into two equal halves will be the equator. So that's the more reason why I have stated here that this includes longitude, so all longitude and the equator. So the equator is the only latitude that is what? A great circle. Please take notes. And great circles, okay, have, okay, radii equal to the radius of the earth, denoted by capital R, I should say. Okay, so when we are dealing with the radius of what? Of we are dealing with a circle. We are talking about circle. Every circle is supposed to have a radius. And when it comes to great circles, the radius is usually represented by capital R. Okay, and small circle. So if your circle is not a great circle, then obviously it becomes a small circle. So a small circle will be the opposite of what? That of a great circle. So any circle that does not divide your earth, your globe, into two equal halves is regarded as a small circle. So please take note. So if you go back here, you can see that, okay, I've already mentioned that all longitude are what? Are great circle. But if you come to the latitude, only the equator is a great circle. The other ones that we have here, okay, you can see that if I have an orange and I cut through up here, okay, you know that it will not divide it into what? Into two equal halves. So the circle that will be formed there will be a small circle. Is my point well made, my professors?
Yes, mm.
Okay, so now, okay, you should note the following. The radius, okay, and small great circles are also, sorry, small circles are represented by small r. Okay, basically. So great circles, big R, R for radius. Okay, small circle, small r, R for radius, as simple as that. So the radius of the earth, capital R, varies between, okay, 6,357 kilometers and 6,378 kilometers. But for calculation purposes, we usually assume, okay, the radius of the earth, that is the capital R, the great radius of what? The great circle is 6,400 kilometers. Am I clear?
Yes, mm.
All right, okay. So because the earth is not a circle, okay, the radius will not be a particular value. Okay, you know, it's a sphere. Okay, so if it's a circle, then your radius will be uniform. Okay, all right. So quickly, let's look at the relationship between your capital R and the small r. That is the radius of a great circle and the radius of what? Of a small circle. And this is it. The radius of a small circle can always be stated in terms of the big circle, which is the great circle. And that will be big R cos what? Theta. Okay, and because of time, I'm not going to prove it. Okay, in fact, if the intention was to prove it, that's the more reason why you have this. You don't need a proof. What you need to know is that, okay, small r is equal to big R cos what? Theta. So you should know this relation. Okay, where this theta here will be the angle of what? Latitude. Okay, so very soon you will know. Don't worry at all. Okay, so now let's look at finding the circumference of what? Of a great and what? Small circle. So you know that every circle, like we did in the mensuration, okay, every circle we should be able to find its perimeter, which is the circumference. So in terms of formula, if you have, okay, a circle, its circumference is given by 2 pi r. Do you remember? Where r, small r is what? Is the radius of what? Of the circle. However, in this case, you know, because we are using small r for small circles, Okay, it means here, this formula, if I quote it in terms of small r, then I'm dealing with what? A small circle. It means my circle that I'm dealing with is that of a small circle. However, if it's that of a great circle, then it will be 2 pi, and in that case, my r will be capital R. Okay, however, you can see that this is the formula that we have there. The circumference of the great circle is what? C, which is equal to 2 pi r. So great circle, the radius is capital R. Circumference of a small circle is equal to 2 pi r. The radius is small r. However, remember, okay, what do? We said we always have a representation for the small r in terms of the big R. And we said that small r is equal to big R cos theta. So wherever I see small r, I can replace it by big R cos theta. Because big R is uniform, okay, not uniform per se, it will be given your R. As for the small circles, okay, we don't know the radius, okay, for small circles, but we know the radius for great circles to be 6,400 kilometers. So if you are dealing with small circles, take it in terms of what? The big circle radius and what? Use that particular formula. So where, again, theta is the angle of the circle of latitude, like I said, okay, earlier. Is my point well made, my professors?
Yes, sir.
Okay, quickly. So now let's look at how to deal with the following. So we are asked to find the radius of the following. So find the radius of the following, okay, circle of latitude. Let me quickly do the editing. Okay. Okay, supposed to be of the following circle of latitudes. Okay, so I think, let me check whether the other one too, of the following longitude. Okay, so I think that's okay. I can go back to my presentation view. Okay, all right. So here you've been given the latitude, and all latitude apart from what? Apart from the equator, is a small circle. So if you're asked to find the radius of what? Of the latitude that you have here, then you are finding the radius of what? Of a small circle. But you know, so here solution, question 1. Okay, I know the radius of question 1A. Okay, what am I giving? Giving your latitude. So latitude is what? 25 degrees or south. Okay, you know the latitude are measured relative to the south and what? And the North Pole. Okay, so whenever you see south, you see north, you know that we are dealing with what? Latitude. So even if I didn't say circle of latitude, you should know that we are dealing with latitude. Okay, because of what? The direction of measurement. So in this case, you know, okay, I can write that, but okay, radius of a small circle, okay, which is small r, is equal to, we know, is capital R cos what? Theta. Is my point well made, my professors?
Yes, please.
Okay, so in this formula, you need the R, capital R and theta. Remember we said theta is what? The angle of latitude. And here the angle of latitude for A is what? 25 degrees. However, your R is given 6,400 km. So it means I can say that, okay, this will be equal to, okay, so I will get, okay, my 6,400, ignore the unit for now, then cos your angle of latitude, which is what? 25 degrees. So I'm going to rely on you. Oops. Okay, so please give me, and let me deal with it some few seconds. Let me deal with this issue. Okay, other than that, it's going to disturb us. Let me clear what you have there first. Okay, so let me pause. Okay, so now we should be good to go at this point. So you use your calculator to give me the, okay, value. So you should know that your final answer should be in kilometers. Okay, so that's it. So give me, use your calculator, give me 6,400, okay, times what? Cos 25 degrees. And I'm waiting. So even at that point, I can have my conclusion drawn. So let me draw my conclusion there. Okay. I'm waiting, my professors. Let's go. Oh, I'm waiting. Don't let us waste time on this. Okay.
5,000.
Okay, so I'll write there for, we're asked to find the radius. So radius, okay, will be equal to 5,000
800.
891.
891. Is it exact?
No, please.
No,
So,
please.
okay, it's a
No,
dot.
please.
Help me, let's go.
5,800.39.
Oh, then you rounded. I've not asked you to round. You know, if you are not asked to approximate, don't approximate. Okay, if you want to approximate, then approximate to 4 dp before any other approximation. So please bear this in mind. Let's go ahead. So give me in terms of digits. So 5,
800.
mm-hmm.
0.3698.
98. Okay. So 4 dp you are approximating. So don't forget your kilometers, that's your units. Then you indicate your approximation in brackets. So 4 dp. Is that clear, my professors?
Yes. Yes.
Okay, so I will do one more. Okay, then after that, we'll move on to the next question. So the next one, B, you leave a line. So B, okay, so this time around, I'll present it maturely. You know, that's always what I do. The first one, I will present it, okay, with some certain step that will help you relate. So in this case, again, I've been giving, okay, 50 degrees north. And okay, north, what we have there is what? A latitude. So if I'm asked to find the radius, I know. So I'll write, okay, therefore, radius, I know the formula. So I know that will be equal to capital R, okay, cos, okay, theta. And that will be equal to, so you come and substitute your R, you are told is 6,400. Ignore the units later, you can bring it. Then cos, okay, we said theta is our angle of latitude, and the angle of latitude there is 50 degrees. Is my point well made?
Yes.
Okay, so I need your calculator value, then we are done. Okay, hurry up.
4,100.
So for
4113.
113
0.8407. 074
07.
dp.
I hope you, when you are rounding, you consider the next digits.
Yes, please.
Okay, so km, okay, then you approximated, so indicate your approximation for dp. Okay, so that will be it for. So in view of that, I believe you should be able to do this and that. Okay, just substitute your theta and use your calculator. As for the R, it will be the same. So what will change will be the theta from one question to the next question. So that will be it for question one. Now let's go and look at what? Question two. Okay, all right. So here we are asked to find the circumference. Okay, as for the radius, there is no way you will be asked to find the radius of a great circle because we know that one we have assumed that it is what 6,400 km. So that one is automatically known. It's the radius of the small circle that will change from one latitude to the other. I hope my point is well made.
Yes.
Okay, so here what do we have? Find the circumference of the following longitude. Okay, so once you are dealing with longitude, what type of circle are you dealing with? Great or small? Great or small? Longitude. All longitude are great circles. Remember I told you, the only latitude that is a great circle is the equator. Okay, which is latitude 0 degrees. Is my point well made?
Yes.
Okay, so all longitude are what? Great circles. So in this case, this is what we are going to do in terms of our presentation. So solution to question 2. Okay, anything for you to underline, okay, longitude. Even if this is not there, you should know that when the angles are measured relative to the west and the east, we are talking about longitude. Latitude are measured relative to the north and south. Okay, so you've been asked to take R as this, then pi as this. So let's go. So A, what do we want to? We've been given, okay, latitude 20, sorry, longitude 20 degrees what? West. Okay, so this is what we have. Now, okay, if you like, you can attach the longitude this. Okay, only that I said it's basically the same. Okay, this can never be a latitude. So now what do? We are looking for the circumference. So I'll write, okay, I'm mature. So let me write the first time round. Okay, so but I know that circumference. okay, will be equal to this circumference of a great circle. Do you agree? And circumference of a circle is 2 pi r. But for a great circle, the r will be capital, so it will give us 2 pi capital R. Is my point well made?
Yes.
So you need the values for pi and r, and you are good to go. So this will be equal to 2. Pi is given as well, so times, you can use brackets. Pi is given as 3.142. Okay, then times, okay, your r, and your r is also given as well, 6400. Okay, so you are looking for circumference, this distance. So the distance will also be in kilometers. Take note, since this is in kilometers. So I will need your calculator value. So that will be your last step. So I'll write therefore, okay, circumference. Remember, I've not left any line. Okay, it's looking as if I've left a line. I've not, because I'm not moving from a sub question. So circumference, let's go, will be equal to, I'm waiting for your value, your calculator value, 2 times this times this. Who has it? 40
217.6.
217.6 exact.
Yes, please.
Okay, so here you add your km. You don't write 1 dp because it's exact. You didn't approximate. Is that clear? Okay, then you move on to the b. Okay, b, this time around I will handle it maturely. Giving, okay, what am I giving? Okay, 30 degrees east. Okay, so it means my angle, or the whatever that I have here, the measurement, the direction is telling me that I'm dealing with longitude. So in this case, I can write therefore circumference. Okay, will be equal to, so I'm assuming I have the whole of this space, I won't come down. Okay, so I'm going to write through the line. So now what do I have? However, if you have a line, then don't write through. Okay, all right, so what do we have? We are going to get what? We said the formula would be 2 pi capital R. So in any case, I didn't write through. So this will be equal to, we go and substitute. So quote the formula, let the formula guide you. So it will be 2 into what? 1 point, oh, sorry, so you are going to get 3.142. That's your pi. Okay, then times your r, which is 6400. Okay, so I'm waiting for your answer, then I will attach my km. Hurry up, my professors. Are you with me, my professors? So you can see that with this one,
Yes, please.
we didn't use, what do you call it? So I'm waiting. It's going to be, is it going to be the same?
Yes, please.
Okay,
Yes,
it's
please.
going to be the same. All right. Okay, so that's what we have there. So you don't struggle. So we are looking for, since, so you should also know, okay, since the radius of a great circle is uniform, the circumference of great circles will also be uniform. Do you get my point? Because they will have the same radius. Remember, every circumference depends on what? The radius. That's the only variable. Okay, but because it's a great circle, the variable r, okay, we know it's indirectly a constant, which is 6,400 km. Okay, so that will not change. So now let's go and look at, okay, the situation where it is latitude. It is latitude that the circles, okay, will change in terms of size. Therefore, okay, the radius will change and the circumference will change. Is that clear, my professors?
Yes, please.
Okay, so now let's look at solution to question 3. Okay, so question 3, okay, find the circumference. So you are finding the circumference of following latitude. Take this. Okay, so now what do we have? A, we've been given, so let's extract. Okay, our latitude, and the latitude is what? So latitude, let me write it this way. Okay, so that at least I'll be more precise. Given latitude, okay, 25, okay, degrees south. That's the latitude. Okay, so now what do? We are looking for circumference. So I'll write, but I think now we are matured. Okay, so I'm going to write therefore, okay, circumference. We know circumference of latitude. Latitude are small circles or great circles?
Small circles.
Small circles. And you know small circles, ordinarily the circumference will be 2 pi small r. But we know that r, okay, has a connection with what? With the big R. So that will give us what we said the formula is 2 pi, okay, big R cos theta. Is that clear? Okay, so you quote down. So it will be
Yes, please.
2 pi, okay, if you like, if you write a small r, you now move on to go and write this. So if you know this later, we write it 2 pi r then cos what? Theta. Where theta we said is the angle of latitude. So if you consider this latitude, what is its angle? 25, Abi.
Yes,
Okay,
sir.
and the r has also been given. So here you were not given pi. Once pi is not given, it means we want you to leave your answer in pi. Don't substitute pi to be 22/7 or pi to be 3.142. Is that clear? Leave your answer in terms of pi because
Yes,
the
sir.
pi value is not given. So this will be equal to, okay, 2, okay, pi, you know your r, that is given. Okay, r is also into 6,400. Okay, then cos theta. Okay, your theta we all agreed is 25 degrees. Okay, so use your calculator to do 2 times 6,400 times what cos 25. Whatever that we get, then we attach. I think we did that one somewhere there. Oh, hey, I think it's here. It's what we have here. Is that not it? Okay, only that you will multiply this one by 2 and that will give you your answer. We've done the R cos. Is my point well made? Oops. Okay, so you
Yes,
just
sir.
use your calculator to give me what you have there. I will attach the pi, okay, and the units. Then we are good to go. Hey, what did you get? My professors. Okay, let's go. Oh, do 2 times 6,400, okay, times cos
1
25.
1.
1
One
1
one six zero zero
116
zero zero
00
point 739
739
7.
7. Okay, that is for DP. Don't
Yes,
forget your
sir.
unit KM. Okay, then okay, you indicate your 4 DP. All correct, my professors.
Mr. Hackman,
Yes, please.
please the pi.
Oh, thank you very much. Okay, all right. Okay, so this one it really escaped me. It wasn't intentional. Okay, all right. Okay, so I think you have to write a pi before your kilometers. So let's go and do the needful. So pi, okay, it should have been costly. Okay, so please take notes. All right. Okay, so I guess with that, should you do one more or you are fine? Is there anyone here who wants us to do one more? So this is just a formula work. Are we all fine, my professors?
Yes, please.
Can I move on to the next question?
Yes, please.
Okay, so the B, it will basically be the same, only that your theta will change to 50. So you use your calculator. Again, don't forget to leave your answer in pi, and you are good to go. Okay. Now, this is it. Okay. With this one, we are asked to find the length of the Tropic of Capricorn. Okay, Tropic of Capricorn is what? Is indirectly a circle. But you need to know whether it is. So if you don't know this, okay, Tropic of Capricorn, you need to know its angle. Okay, and you need to know whether it is a latitude or longitude. And I said that information anyway. Let me ask whether you know that. Tropic of Capricorn, is it a latitude or a longitude? Make your JHS teachers proud. And geography students, okay, make your geography teachers proud. Latitude or longitude? Okay, so if you don't know, there is no way you can proceed. So that's the more reason why what you learn in JHS, okay, you don't throw everything away. Okay, this is smart, but here is the case you are. So I will take you back a little, just a little. You have that information there. Okay, so remember, okay, I stated key latitude. Okay, the equator, which we all know, that's a special one. Angles are measured, the latitude are measured relative to the equator. So Tropic of Cancer, Tropic of Capricorn, okay, and you know this is it. So Tropic of Capricorn, okay, will be 23.5 degrees south. So instead of giving you this, okay, 23.5 degrees south to be of the nature of the question that we've handled so far, okay, I only mentioned, okay, Tropic of Capricorn. Okay, so you should know that Tropic of Capricorn is the same as 23.5 degrees south. So it's a small circle, and therefore when you quote, you involve theta, so you know you will need this. Okay, and its opposite is what we call Tropic of Cancer. Is my point well made, my professors? Okay, so with this one, indirectly, this is what you've been given. So giving, okay, your latitude, so your latitude or giving Tropic of Capricorn. And we know Tropic of Capricorn is what? 23.5 degrees, oops, okay, 23.5 degrees what? South or north?
South.
So,
Okay, south. Okay, so with this one, you know it's a small, once you see south, you know there's a small circle. You are finding its length, so you are finding the circumference. So you write therefore, okay, length. Okay, you go by what you have there. You know that length is the same as the circumference. Okay, its length will be equal to 2 pi small r, but small r in terms of big R will be r cos theta. So here your theta will be 23.5. Your r, okay, is not given. Okay, I think I should have added the r. Okay, but the r usually will be what? 6,000. That is exact. So 6,000, okay, 400 kilometers. So you substitute, then you move on. Oh, my point well made. So here I just wanted you to know that we can make use of for some of the key latitude and longitude in the question. So know them and know their angles. Is that okay, my professors?
Yes, please.
Okay, so now, okay, let's look at how to locate, okay, points on the Earth's surface. Okay, location of points on the Earth's surface. Okay, any questions before we come to this? Okay, so you are fine. All right, so we thank God. Okay, so now this is it. Take note. Anytime you are dealing with points in terms of the Cartesian, okay, every point is supposed to have x coordinate and y coordinate. Do you agree? So if you want to locate a point on the Cartesian plane, if I give you only the x coordinate, there is no way you can locate the point. You know where the point will be, but you don't know the exact, okay, position of the point. You have a rough idea of where possibly the point could be, but its actual position, no, unless I give you the y coordinate as well. Okay, however, please take note. Anytime, so this will be the x coordinate, the y coordinate. However, if we are dealing with, okay, the earth, okay, your point, the x coordinates will be given by latitude, and the y coordinates will be given by the longitude. Is my point well made?
No, sir. Please come
Yes,
again.
please.
Okay, so you can see, let's use this picture. That's the more reason why I have this. If you look at this picture, you can see that these lines, the power lines that you have there, which usually you draw it as a line, but they are usually curves. They are not lines. Okay, they are curves. Okay, they are not exactly lines. So you should know that. That's why when you cut through, you get a circle. You get what? Okay, line. So in this case, okay, you can see that if I'm dealing with this, these ones are moving like the x-axis. Can you see that? Are you with me? They are
Yes,
moving
please.
like the x-axis. So it means indirectly your S coordinates will be represented by the latitude because these are the latitude. The one moving like the S axis, okay, are the latitude. Do you agree with me? So your S coordinate in terms of the globe will be the latitude, and the Y coordinate, you can see that it will be this one, okay, moving like the Y axis. Okay, moving like the Y axis. So indirectly, we are talking of what? Okay, your longitude being what? The Y coordinate. So it will be latitude, longitude. So every point, okay, if you want to locate the point on the Earth surface, we need its latitude as well as what? Its longitude. So where the latitude and the longitude meet, that's where your point will be. So it means here, okay, there is a point here. Okay, this is a point on the Earth surface. I know the exact point where a latitude meets what? A longitude. There's also a latitude meeting a longitude. So where they meet, these are all points that you can easily, okay, locate them. Okay, to get the exact point. Without the longitude and only the latitude, you cannot. Okay, and vice versa. They move together to have the exact location of the point. So with this one, today's the actual situation. Okay, they will all be curves. So this where they meet here. This is where your exact locations will be. Is my point well made now? Is it clear now?
Yes, sir.
Okay, so that will be whatever you have there. So if I am asked to locate a point, I think the next example will bring us that. So let me use that one, okay, to deal with it. Okay, so let's look at, okay, the location of points on, okay, the Earth's surface. Okay, how to locate point. If you are able to do this, all that we are going to do, okay, we rely on this because you have to draw and locate the point before you be able to do whatever that we want to do, okay, from here going. All right. So let's see the first question. And again, I will do possibly maybe the first two questions. Okay, locate the following points, okay, on the Earth surface. So here we are dealing with only one point. So this is what I will entreat you to do. First of all, draw your indirectly your y-axis, which is the meridian, the 0 degrees, your true north. Okay, oops. Okay, so this is what we have. Okay, I'm using my free hand, but you will not use your free hand. And again, okay, so this will be your north, okay, pole and your south pole. You can use north and south, okay, southward pole. That's what you have. Then you can also bring in the equator. So this will be the equator. Okay, so the equator we know. So this indirectly will be 0. That's the equator. So that will be your, okay, west, okay, east. Point well made. So I've drawn my special gray circles, one for the latitude and one for the longitude. So now let's see. The reason why we are doing this is that longitude and latitude are measured relative to these special lines. I hope you are with me. So that's the more reason why I will always advise you indicate them so that it will tell you how further you are supposed to move away from that line, though you are not drawing to scale. So let's look at 20 degrees south. So this is the line dividing, okay, your sphere into north and south. So if I'm looking at 20 degrees south, it means I am moving 20 degrees from this line. So I'm going to draw it this way. So, okay, 20 degrees. So this is what I have. I hope you are with me. So I'm going to indicate this as 20 degrees towards south. Should I come again or my point is well made?
Please come again.
Okay, so let's go back to, okay, you can see that at normal circumstances, how we draw our, okay, what do you call it? The latitude. Okay, it will be circles, okay, or arcs moving in this direction. Okay, and longitude usually will use, they will not move, we don't draw longitude this way. Okay, for the latitude, okay, you know that they will be moving in this direction. Okay, they are parallel, so that will be it. For the longitude, okay, so if I'm drawing, let me draw a circle. Longitude, immediately you do this, okay. When you are drawing the one to the west, okay, this is how you draw them. Okay, you curve them this way. If you are drawing the one to the east, this is how you draw them. I hope you are with me. You don't draw all of them this way, moving in one direction. You get my point? Are you with me? Is my point well made now?
Yes, sir.
Okay, so now that's exactly what you know. This is your 0 degrees. This is 0 degrees. Okay, your equator, 0 degrees. So let me write maybe 0 degrees here. That's your equator. Okay, so 0 degrees, and we said, okay, the what do you call latitude? I measure 0 degrees up towards the pole here, which will give you 90 degrees. So you will not have any latitude that is greater than 90. So it's like you are not drawing to scale. So from here, I'm moving 20 degrees away from what? My 0 degrees. So that's how I draw it. If it was to be, okay, not, then I would have drawn the line up, okay, here. Is my point well made? But it will be a curve, not a line. Hope my point is now well made.
Yes.
Okay, so on that note, let me clear this. I don't need this now. So I've been able to locate my 20 degrees south, okay, which is my latitude. Now let's go and look at what that of what the longitude. So longitude, what are we supposed? What's the longitude here? 15 degrees what west. So you know this is the line dividing your globe into west and what and east. So 15 degrees west, you know this is your 0. So you move a little away 15 degrees. But that one, they will always converge at what? The north and south pole. So that one, this one, they will not converge here. Okay, so please take note because they don't meet. Okay, so I will draw it this way. Oops. Oops. Okay. It's moving in this direction. Okay, and which angle are we referring to? This one is what? 15, okay, degrees what? West. Are you with me, my professors?
Yes,
Are you
please.
with me?
Yes.
Okay, so where your 20 degrees south, okay, curve, and that of what? The 15 degrees west, they meet. That is where your point will be located. Okay, so the point of intersection here is what we call the A. Afa, my professors, is my point well made, my professors?
Yes, please.
Okay, so we are going to do one more, okay, or we will do more, don't worry. So the next one, this is what we are going to do. We are going to do the B. So this is the solution for A. Remember 1A, I didn't number my solution. So 1B. Okay, you will draw a circle. Okay, we know it is not directly a circle, but you can draw a circle. It's not drawn to scale. Okay, so when you are drawing your circle, or the drawing that we have here, you don't use what? Pen. It should be in ink. Take notes, and you use the right instrument too. So we are going to have our, okay, north, okay, south. Okay, so the north pole, the south pole, or you can use north south. And so that's my special what do you call it, longitude, the Greenwich meridian, 0 degrees. Then I'll come and get that of what? My latitude. It doesn't really matter which one you draw first, okay, because your latitude and longitude are measured relative to these special lines. So that's the more reason why I will entreat you to. Okay, so this one is your 0 degrees. This will indirectly also be 0, okay, degrees. Okay, so if you are measuring, but you measure. So in this case, this is what we are going to do. We said the latitude here, so this is also A. In fact, I think I wanted to change this one to B. It doesn't really matter. Okay, it is A. So you still label it as such. Okay, so now this is your west, this is your east, if you like. Okay, so now what do we go? What do you do from here? 76 degrees south. So it means, okay, let me see. Somebody has sent a message. Okay, let me see. Okay, so Prof. The Nature, I know maybe you won't start exactly at what, so wait for maybe 5 minutes, okay, or 10 minutes, okay, to time, because today being your first meeting, that's how it's going to be. Okay, so stay with me for a while.
Okay, sir, but I just
Uh,
wanted to alert you ahead of time.
oh, okay, all right, okay, so that's okay. Okay, all right. But I think I may ask for you, you've had our arrangement already. Okay,
Yes,
so
please.
that's it. But it's good for you. You prompted me. Okay, that is respect. Okay, all right. So let's go. So in this case, we are looking for 76 degrees south. So it means again, you are going to, I think I should have gone for one in the north, but it doesn't really matter. We'll do more. Okay, so 76 degrees south. So I will move okay, farther away from this. Remember, from here to here will be what? 90. So I can move here. Okay, 76 maybe somewhere here. I draw it this way. So this will be my 76 degrees towards south, which is my latitude, 76 degrees south. Okay, then I go to my longitude. Longitude is again 15 degrees west. So west is to the side. So that one you will draw it, okay, this way. Okay, so this is what your 15 degrees what west. So where the 76 degrees south and the 15 degrees west meet, which will be this point, is what we are going to label as our point A. Afan.
Mr. Hackman,
Yes, please.
please, when you are drawing the latitudes and longitudes, are you supposed to use a protractor or we assume their positions?
No, no, no. The only thing that you use instrument to draw will be your circle and maybe your special lines, or your equator and this one. Okay, the rest you use your free hand.
Yes, please.
Okay, all right. Okay, so that will be it. Okay, however, make sure it's still beautiful. Even mine that I'm using the guitar, you can see that it's nice. So when you are drawing this arc, okay, and you are shaking, then you should know, okay, that you are under intention. All right, so that was just by the way. So let's move on. I almost said, okay, immediately you do that, then it means you have to say no to alcohol. All right. Okay, so let's move on. That was just by the way. So we are done with B. Okay, we are going to do, okay, the two more, because all along that's what we are going to do. But before that, let me quickly, okay, I think later I can do that. Okay, so let's go. So we are going to look at this. Our next one, C. Okay, but okay, all of them, okay, you extract, giving this, giving that before you come and draw. Is that okay? You know that I decided not to extract.
Yes.
Okay, that's for this one, you all know. So C, you extract, giving, okay, that whatever you have there. Then now you come to, okay, relative, okay, the latitude are measured relative to the equator. So I'm going to indicate my equator, which is what, 0 degrees. Longitude are measured, okay, relative to the meridian, the Greenwich meridian. Okay, so we, okay, do this. I'm using my free hand, but you will use a straight edge. So that is your north, okay, then your south. Okay, you can choose not to indicate your poles. And this will be west, okay, and east. Okay, so now you know your baseline for each of them. So the next one, we are looking at 10 degrees north. So 10 degrees north, or 10 degrees above what? This line north. So that means I'm going to draw it, okay, this way. Okay, but it's supposed to look like a circle, an arc, not rather than a line. Take note. So this is my 10 degrees, okay, north. Is that clear, my professors? My professors, my point well made.
Yes,
Hello.
Yes,
please.
please.
Okay. All right. Then the next, okay, one is 20 degrees east. Okay. So east, this is the east. This is what you will divide into west and east. So east, when you the latitude, sorry, the longitude, if you are indicating, you start from here. So 20. So, okay, I'm going to do this up to what you have here. Great. Okay. So this will be my longitude. Okay. 20 degrees what? East. Okay, so where this longitude and the latitude meet, okay, this is it. Okay, that will give you your point C. So this is what the point was, C. Afa. Hello, all correct, my professors.
Yes, please.
Okay, all right. So I guess with that, we should be able to do this particular one. Okay, so you try this one. Okay, as well. So what you have here indicates, so south, okay, so meaning it will come down, then the east will be here. Okay, so that will be it. Where they meet will be where you have that. So it's the same thing, locate the following points, only that this time round you are dealing with 2 points, and likely that's where we are going to end. The other one, were dealing with only 1 point, but basically it's the same concept that we are going to use. If you can indicate 1 point, you should be able to indicate 2 points, because 2 points, each point will have the same situation that we are going to deal with. So in this case, what do? We are going to look at solution to question 2 and question 2a. Okay, we are just asked to indicate, so given. Okay, so let me see a message. Okay, all right, that's okay. So all Econ students, okay, please, if you want to, let me pause the video and make this announcement. Okay, so I think the Econ students, my message sent to you received very well. So now let's look at this one, A, giving, okay, this point and that point. So I'm going to indicate 2 points. So again, what do I do? Oops, I will indicate my north-south. Oops, okay, but I'll manage. Then my equator and my way. So this one is 0 degrees. Okay, that is east, then west. Okay, then south and what? And north. Okay, that must be indicated. So let's go and indicate the first point. 20 degrees south. So 20 degrees south, you come down. So that will give us what we have here. So that will be your 20 degrees south. Okay, then 15 degrees west. So 15 degrees west, west will be here. And that one, you do this 15 degrees what? West. So that is 15 degrees west. So this is what we have here. Oops. Okay, I think no issues. That's okay. I think my point will be made. So this will be, okay, let me write it here. 15 degrees west, 15 degrees west. Okay, so usually this one you have to, okay, draw a line to indicate that. As you can do it above or below. Okay, you indicate, you can do this. Okay, or that. But usually when we use arrow, it's like in scientifically, we are talking about the same, that exact point there. So usually don't want you to use an arrow. Okay, so, okay, let me see if I can clear that. So don't use the arrow, just use your, okay, your normal line. Okay, so let's go. Oops, okay, so this will go. I've made my point up there. Okay, so now let's go. So where this latitude and the longitude meet, that's where you are going to, okay, get your point M. So my first point located. Okay, now it's left with the second point. The second point is N, and that is 20 degrees north. 20 degrees north, and that is here. So it means I'm going to, this is 2020, so it means you should look closer, though not, okay, drawn to scale. So 20 degrees, okay, north. That's my latitude for the second point. What's the longitude? 15 degrees west. You've already drawn that. So it means where this line or curve and this curve meet, that's where you are going to get your N. Point well made, my professors. Afa.
Yes,
Hello, are
please.
we fine? Okay, so we will do one more here. Maybe even we are left with only one. So we'll do the B here. All that we are doing here, please make sure you get it. Oh, it's for a particular future. It holds a key to a certain future. Okay, a typical the Earth as a sphere global mass questions. Okay, usually you'll be given points and you'll be asked to find the distance between the 2 points, the shortest distance, what have you. Okay, so let's go and look at this one. Okay, I think, okay, so we have this. Oops, we are there. Then this one. Okay, so your 0 degrees, your equator. So this will be east. Okay, west. Okay, then north, south. Okay, so now take note. Okay, remember, this is what we are going to do. The point here, P, 30 degrees south. So 30 degrees south, I need to come down. So usually consider your other one. So this is also 30 degrees, 30 degrees. So I think that one will be the same thing. So 30 degrees, I'll come down a little. Okay, it's not drawn to scale though, I've told you. Okay, so this is your 30 degrees, okay, south. So the next one is what? 45 degrees east. So this is east. East is to the side, okay, west. So 45, I will move a little bit away. So 45 will be somewhere here. So this will be my 45 degrees what east, which is what my longitude. So where this longitude and the first latitude they meet, that is where your point P is going to be. So this is P. All correct. My professors, is my point well made?
Yes, please.
Okay, so it's left with one more point, which is the Q. Okay, so that one to 30 degrees south, that is already drawn. Okay, then 25 degrees west, that is not drawn. So we are going to draw that one. Remember, this one is 45. So 25 should look closer to this line than to this. Okay, so in this case, we are going to draw that one a little closer, though it's not drawn to scale. Do you get the point? So this will give you your 25, okay, degrees west. Okay, so where this 25 degrees west and the 30 degrees south, okay, meets, that's where your point Q is going to be. Safa. All correct, my professors. Hello, my professors. Are we all fine? Is everyone okay up to this point?
Yes, please.
Okay, so on this note, I think you should be able to do this. Okay, the two, you should be able to do that. I think, let me see, okay, it's the same thing. Okay, but that one, okay, I repeated, let me see, is it the same two, KTS, is the same thing. I repeated, we shouldn't have been because, okay, we're dealing with only, okay, these two. So I will delete it in the slide before I send it to you. Then the third one, okay, so ABC basically will be the same thing. You should be able to deal with it. Okay, the same thing. You are indicating 2 points. Okay, so once you all okay got the first two okay that we've done here, you should be able to deal with the rest. Okay, so now we are going to look at this, and okay, this was supposed to be my target. Okay, how to find the difference in angle between 2 points, okay, on the Earth surface. So this is where we are going to end, and I pray that my battery life will, okay, will help me to explain this. It doesn't cut me along, okay, the line. So let me check before, okay. Okay, so okay, this is going to be the end of what today's lesson. Okay, in our next meeting, we'll look at how to find the differences, the difference in angles between 2 points. In actual fact, find angles between two okay points on the Earth's surface. And here you are talking about the points being on the Earth's surface. Okay, so I think our main objectives for today's lesson, okay, well attained. Okay, so on that note. Okay, thank you very much. Okay, may God bless us all.